Hello, hello. Welcome to 10.9 FM because today is 10th of September. Let's start with the topic for today, which is melting and freezing point. What is the difference between melting and freezing point? Let's look at a graph. So imagine you have this graph of temperature versus time. Okay, let's draw this longer. Okay, this is ugly. Let me draw it again. Okay. Let's say a substance. We start from, like, say, negative 30 degrees Celsius. And when we heat it up, or when it absorbs heat, then it will increase in temperature. It will increase up until one point. Then the temperature will stop increasing, even though it keeps absorbing heat. Why? Because at this temperature, this substance, it starts to melt. So this is the point where the melting begins. And this is solid state, by the way. And solid means we have a solid, very proper, uniform, orderly arrangement of the particles. And after this point, when it reaches this point, this is the point where the particles start to rearrange. It breaks from its orderly arrangement. And that is how it turns to liquid. That means it's still close together, but not in order. So this is the point where melting begins, and this is the point where the melting completed. Melting completed means there's no more solid. All solid has been turned into liquid. So this in the middle is solid plus liquid. Okay, so when the solid starts to melt, then it means that the molecular structure or the atomic structure, the particle, start to break from its orderly arrangement. Then we can see that the arrangement change from the left to the right side. Until all the solid has changed to liquid, then only the temperature can rise. And this is only liquid. It's like ice water. Ice water contains ice and water. So this is where the temperature of the drinks is at 0. It cannot increase in temperature until all the ice melted into water. Then only the temperature of the water can increase from 0 to 1 to 2 to 3 to 4 to 5, 6, 7, 8. That's why when people say that the temperature of the ice, in the ice water, the temperature of ice is 0. The temperature of the water also 0. So 0 means that it is a temperature of the ice or the temperature of the water. So it's a mixture of ice and water, depending on whether you are talking about this point or somewhere in between. If this point number 1, it is all still ice. It starts to melt. It just started to melt. And this is ice water, where you have the combination of ice and water at 0 degrees Celsius. And over here, point number 3, you have all water at 0 degrees Celsius, just completed the melting process. Then only the temperature can increase to 1 degree, 2 degrees, 2, 3, 4, 5, 6, 7, 8, 9, 10, until 100. Then same thing happened. The liquid arrangement would change to the gas arrangement. And that is where the graph went flat again. It will go flat again. Okay, but now today we're talking about melting and freezing. We're not talking about the boiling. So this is the melting part. And this is the process of heating. Let's look at cooling. So imagine we have the same graph. This is temperature. And this is time. And this is the freezing part. And this is cooling. Freezing requires cooling, right? Then the temperature of the water or of the liquid will drop because it cools down. It will continue to drop until it reaches the freezing point. Then it starts to flat. So this is the point where the freezing begins. Okay, that means the liquid start to form solid already, start to form its first solid. And then this point is where the freezing completed. That means 100% of the liquid has turned into solid. This one is still 100% liquid. This point is 100% solid. So in between, you have liquid plus solid. Why? Because this disorderly arrangement of the liquid has now cooled down and it forms back the orderly and uniform arrangement of the solid. And that is when the energy released out as a form of heat so that it cools down and it forms back the solid arrangement until all the liquid has formed the solid arrangement and there's no liquid left to form the solid arrangement. Then that is where the graph will go down again. Okay, when all the liquid has been formed or has been frozen into solid, then the temperature will go down, go down, go down, go down until the end. Okay, so that's why the temperature here, whether it's freezing or melting, it's the same temperature, but what happens in between is different. Okay, so that is the difference between the melting and freezing. Hope you can understand. There's more than 1 minute. See you tomorrow.